Good morning all. Today we'll be learning about superposition principle. It is very simple. If you have two waves, okay, we just imagine y1 and y2. Then what is the resultant of the displacement at any particular point? Suppose this point, okay. So these waves has to travel in one medium and they have to go in the same time. Then the resultant displacement will be the vector sum of the displacements due to this y1 and y2. That means it is due to individual vector sum of the individual waves. Therefore, total displacement y is equal to, if it is y1, y2, etc. There are many waves and you can put y is equal to y1 plus y2 plus etc. So here you can see that you can see a blue wave and also a green wave. They are traveling, and red is the resultant of this wave. So what is beats? Suppose, as before we told, there are two waves. Here we have nearly the same frequency. It can have the same amplitude or different amplitude, and they are traveling in the same direction. Then the resultant displacement will have waxes and wanes in amplitude. That is, it will increase that. The amplitude will be doubled. So that is called the waxing. Waning means it will be diminished. So it is waning. So waxing, enhancing and diminishing. So this waxing and waning of the resultant amplitude is called the beats. Now we have to look into the mathematical treatment of beats. So it is mathematical So first of all, we have to consider two waves. The simplest case, the frequencies are nu1 and nu2, having amplitudes a1 and a2. So frequency nu1 with having amplitude a1 and frequency nu2 having amplitude a2. With the condition that nu1 minus nu2 is very small. Now, how do you represent these two waves? So, the first wave has a frequency nu1 and amplitude a1. So, displacement y1 is equal to a1 sine 2 pi into nu1t. Similarly, the second displacement of the wave is a2 sine 2 pi nu2t. So let me just give it equation numbers. So your first equation number is y is equal to y1 plus y2, and second and third equations are y1 is equal to a1 sine 2 pi by lambda, 2 pi nu1t, and the second displacement is a2 sine 2 pi nu2t. Therefore, total displacement y is equal to y1 plus y2 from superposition principle. Now you just substitute for y1 and y2. So y is equal to a1 sine 2 pi nu1t plus a2 sine 2 pi nu2t. Let me give it another color. Now this nu2, you can be written as nu2 is equal to nu 1 minus nu 2, right? So it is also, so you can see that nu 1 and nu 1 gets cancelled and minus will be absorbed inside, it will be plus nu 2. So I will give this equation number 4 and this is my fifth equation. Substituting 5 in 4. What will you get? Y is equal to a sine 2 pi nu 1t a1 sine plus a2 sine 2 pi. So what is your nu 2? Nu 1 minus nu 2 the whole into t. Okay, this I'll put it as equation number 6. Now what is sine? This is a and this is b. Okay, so sine a minus b. It is sine a cos b minus cos a sin b. So using that formula, you can write the second term in equation 6 on the right hand side as y is equal to a1 sine 2 pi nu 1t, I write it that way itself, plus a2 sin a, sin nu 1 cos b, cos nu 1 minus nu 2, nu 1t, nu 1 minus nu 2 into, sorry, there is 2 pi also, so I just forgot to write that. That also you have to include 2 pi nu 1t and cos 2 pi nu 1 minus nu 2 into t plus minus a2 cos a, so cos 2 pi nu 1t sin b, that is 2 pi nu 1 minus nu 2t. So I'll put it as equation number 7. Now I'll just take all these nu 1 terms to one side. Sin 2 pi nu 1 terms. Here I have 1. Here also I have 1. Okay. So I can write it as y is equal to. So sin 2 pi nu 1t, I take it outside. So the contribution is only a1 here. Here it is a2 and cos plus a2 cos 2 pi nu 1 minus nu 2 into t. Now I pick cos 2 pi outside. That is only one term here. So I write it as minus cos 2 pi nu 1t into, it will be a2 sin 2 pi, this one, okay, nu 1 minus nu 2 into t. Let me put this as equation number 8. So I'm going to make some substitutions. That is a1, this term, a1 plus a2 cos 2 pi nu 1 minus nu 2 into t. I put it as equal to a cos theta and A2 sine 2 pi into nu 1 minus nu 2 into t as equal to A sine theta. Okay. So this is my 9th equation. This is my 10th equation. Therefore, substituting 9 and 10 in 8. What will that equation be look like? Y is equal to sine 2 pi nu 1 t. So this I am going to put it as A cos theta. So I am going to put here A cos theta minus this is A sin theta. So I am going to write it here as A sin theta into cos 2 pi nu 1 t. That's my 11th equation. So you can see that it is sin A cos B minus cos A sin B. So I can write this as, I can take A outside, y is equal to A sin 2 pi nu 1 t minus theta. So I got a very simple equation, y is equal to A sin 2 pi nu 1 t minus theta. Equation 12 suggests that the net displacement of the particle, it oscillates with an amplitude capital A and frequency nu 1, and it lags behind the displacement of the first wave by an angle theta. Using equations 9 and 10, we can find out A. How do you find out A? You have to square and add. So on the right hand side you can see that it's A square cos square theta plus A square sin square theta. So it will become A square, and from that you can get A. So squaring and adding equations 9 and 10. A square is equal to A1 square plus A2 square cos square 2 pi nu 1 minus nu 2 t plus 2A1 A2 cos 2 pi nu 1 minus nu 2 t plus, and you have here A2, this also you have to square, sin square 2 pi nu A2 square sin square 2 pi nu 1 minus nu 2 into t. So look here, we have A2 squares cos square 2 pi nu 1 minus nu 2 and A2 square sin square. So if you take A2 square also, this will become 1. So this is equal to A1 square plus A2 square plus 2 A1 A2 cos 2 pi nu 1 minus nu 2 into t, and your A will be just under root of this equation. So that's my equation number 13. So you have got the amplitude for the total displacement. In order to get the angle theta, that's also unknown. What you have to do? you have to find this tan theta. That tan theta is sin theta by cos theta. That is 10 by 9. Therefore, dividing we have tan theta is equal to A1 sin 2 pi u1 minus u2t divided by A1 plus A2 cos 2 pi u1 minus u2t. And we can see that both are A, the amplitude A and theta are time dependent. See, they are time dependent. So we have to consider some special cases. First case, when 2 pi nu1 minus nu2, okay, 2 pi nu1 minus nu2 into t is equal to 2n pi, some constant where n is equal to 0, 1, 2, 3, etc. What will be the amplitude? Look. So my amplitude is, I'll just pick this up, the 13th equation. Put it here, paste. So now I am going to substitute 2 pi nu1 minus nu2t as 2n pi. So that my A will be equal to, A is equal to root of A1 square plus A2 square plus 2A1 A2 cos, this is 2 pi, no, into 2 pi n into t. So what will be that equal to? Cos of 2 pi n, that is, it will be cos 0 and that will be equal to 1. So this equation will be root of A1 square plus A2 square plus 2A1 A2, or it is equal to A1 plus A2 the whole square under root, or it is just A is equal to A1 plus A2 is the maximum amplitude. Therefore, we can just define it in the opposite way to get a maxima or maximum amplitude. The condition is, so you know, t must be 2 pi nu1 minus nu2 t is equal to, so this is the condition. Okay, so this is the condition. So from this, what is t is equal to? T is equal to, this and this will get cancelled among this. So t is equal to n divided by mu1 minus mu2. And you know n is equal to 1, 2, 3, etc. So what is the condition for maximum amplitude? So n can be 0 Okay, 0, 1, 2, 3. So it is 0, comma, n1. So you have 1 u1 minus u2. 2 means 2 by u1 minus u2, etc. Okay. Now we apply another condition. This is the first condition. Okay, this is the first condition. I will just give it an equation number 14. This 15. Okay. Next condition is that we are just putting 2 pi nu1 case 2. Okay, it's case 2. 2 pi nu1 minus nu2 into t as equal to 2k plus 1. Sorry, this is we have put it as n. So we'll just put it here also as n. 2n plus 1. Now we'll just look into substituting for this equation. Let's see how. Okay, I have that. Not this one, no? This is one. Okay, fine. Yeah, equation number 13. So here again you put it 2n plus 1. So what will you get? Is equal to root of a1 square plus a2 square plus 2a1 a2 into cos of 2n plus 1 into t. So 2n plus 1 means when n is equal to 0, what happens? You have cos t. Cos 2n plus 1 pi. Okay. And it will be minus 1. So this will become root of a1 square plus a2 square minus 2a1 a2, or this is equal to a1 minus a2 the whole square under root, or it is equal to a1 minus 8. So it is a case for minimum amplitude. So the case for minimum amplitude is, what is the condition? 2 pi nu1 minus nu2 into t is equal to 2n plus 1 pi. Okay. 2 pi nu1 minus nu2 t is equal to 2n plus 1 pi, or t is equal to 2n plus 1 divided by u1 minus u2. Now we put your equations n equal to 0. So it is 1 divided by u1 minus by 2 is also there, right? 1 minus that's 1 minus 0 is 1 by 2, no, 1 by 2 into u1 minus u2. Then if you put it 1 equal to 1, it is 3 by 2 u1 minus u2, and it goes on. You have 5 by 2 into u1 minus u2, etc. So that is the condition for minimum. Okay, this is my 16th equation, I believe, right? So for maximum, the condition is t must be equal to, what is it, 0, 1 by nu1 minus nu2, or 2 nu1 minus nu2, etc. And for condition for minimum is 1 by 2 nu1 minus nu2, 3 by 2 nu1 minus nu2, and 5 by 2 nu1 minus nu2. Therefore, note that the maximum minimum of the amplitude occur alternately after an interval of, what is it, 1 by 2 nu1 minus nu2. So the time interval between successive maxima and minima are 1 by nu1 minus nu2. Number of beats per second produced per second, that is the beat frequency. Okay, that is a beat frequency. So learn it well. It's quite an interesting mathematical treatment for beats. Okay, thank you.